There we go. Okay. A great way to talk to me is here. This is the time that everyone wants to talk to me, so take use of it. This link right up here opens a Zoom. It's available Monday through Thursday from 8:30 to 11 a.m. It's been there all semester. You just click that, and there I am. Today, someone came in while I was driving here to work. It's been so sporadically attended that sometimes I'm like doing other things, which is maybe not. I shouldn't, but I will be there, and I will be happy to answer any questions you have. Okay, so any other questions that are like good for that are worth everyone hearing about, or I can also stay after and answer individual questions if as they come up. So today we're doing, oh, I got the wrong. We're supposed to be doing 4-4. And somehow I opened 4-3. So give me just a second. Oh. Thing loaded. All right, well, we're going to have to do it this way. Okay, here we go. So 4-4, we are going to establish the difference between what's called a population and a sample. And we're going to look at these different types of sampling methods to collect data. And then we're going to look at ways to organize this data, specifically with frequency distributions, and then also with stem and leaf plots. So that's our goal for today. So what we're studying now, what we're moving into, we did the probability things on Monday. What we're doing now is statistics. And statistics is essentially the study of data, the study of information. How do we organize it? How do we interpret it and analyze it? How do we use it to answer questions? So one of the big things is to make sure we understand what exactly do we mean by data. And these are measurements or observations that we gather from some sort of study that we're doing. So in statistics, there's like this thing we do. We ask a question that we want to answer. It's kind of like the scientific process. And we just recently had an election, right? There's still runoff elections going on places and people certifying counts and blah, blah, blah. But running up to the election, statisticians are always trying to predict who's going to win. And it's a really useful thing, especially if you're a candidate and you're wanting to know, should I run? Should I try to spend money and time and energy to try to get elected, to become an elected official? And so what you want to figure out is, how are people going to vote? Are they going to vote for me? What messages am I putting out that are helping me be voted for, that kind of thing? And because it's kind of impossible to talk to everyone in a state or in the nation, you take a small group and ask them the question, who are you going to vote for? And from that small group, you make a prediction about the whole group. So the question that you're asking is, who are people going to vote for? The data we're collecting is the names they're going to vote for. Those would be the measurements or the observations. We would then organize all that and calculate some what we call statistics from that, and then use that to make a prediction about the population. That's kind of the big picture that we're doing here. The world we live in now is a data driven. I mean, like, everything is data. Amazon has reams and reams and terabytes and like all of that of data about your clicks as you look through Amazon. And there's algorithms, which are just fancy terms for equations, that are determining what ads to send to you to convince you to click. And they're watching, like, how long are you staying on particular things, like where is your mouse. Facebook does similar stuff. If you ever wondered, like, how do you get ads on Facebook or on YouTube based on different things, it's related on these algorithms and stuff that they're seeing you do. So it's all this data world, and it's all about, in this day and age, social media, it's all about eye time, keeping your eyes on the screen and scrolling through and clicking things so that we can sell you something to make money. I mean, to the social media world, you are a dollar sign. That's all you are. Okay, so here's a question we're going to try to answer. This is the big thing, and we're going to use statistics to try to answer that question. And that is, are grades being inflated? So I don't know if you've heard of the saying, back when I went to school, I had to walk uphill both ways, barefoot in the snow, carrying my 12 brothers and sisters. And, school was hard and I earned my grade. Nowadays, they just give kids grades, all that mess. That idea, that kind of thought process or claim, also that's a nostalgic thing about how everything in the olden days was better than now. There's political campaigns that tried to use that language, right? The thing about grade is that, students are just getting grades easily. We're just handing them out. And so one of the ways we could test that is to look at the average grade point averages for students over the years and see, is there a difference between back in the day, whatever that means, and now? So here's a data set. Someone went out, they went to this gradeinflation.com website, and they took the average undergraduate GPA from these select years, 1983 up to 2013. So here are the GPAs. Just glancing at that, what do y'all notice about those GPAs? What seems to be going on there? Yeah, they look to be getting bigger, right? So the average GPA back in 1983 was 2.83. Now in 2013, well, not now, but back in 2013, it was 3.15. So that's going from like a C plus sort of GPA to a B, or B minus GPA, average GPA. Okay, so there should be some questions we should ask ourselves. Number one, what's the data set? Like, where did these numbers come from? Number two, we should make sure we understand, what does average mean? Like, what do we mean by that? And from that, we might start making these, we could then start talking about the reality of what's happening here. Now, we can also talk about some conclusions, like some reasons that the GPA might be going up. It could be like inflation suggests that things are just being given away. It's kind of a negative thing. If you think about the economy and inflation, it means the price of goods are going up for no apparent reason. Well, there are reasons behind it, but it's a negative thing. Here, the idea, I think the suggestion is that professors are handing out grades to students. We're just raising the grades. But there could be other thoughts going on here. It could be maybe we're better educators. So maybe how we teach students has improved. It could be students are better students. We have brighter and better performing students than we did in the day. Or it could be like we're just trying to look good, and so we give away grades. And there could be other options. So let's get to our first question here. There we go. So this has answers, and I have to erase them. So, oh, we were asked, do we think it's, you all said it, do you think it, sorry. Maybe there's a different, better way to do this. Do we think it supports it? Yeah, because the grades are going up. So we start with the question, is grade inflation a real phenomenon? We gathered the data, and then we just glanced at the table, and the numbers were going up. So now a really important question, how do we think this was calculated? So does anyone know what we mean by average, or how average is calculated? Well, I think the most common thing I've heard people say for average is add up all the grades, divide by how many students. That's the arithmetic mean. So add all GPAs, divide by number of grades, so number of students. That's the basic definition. When we get into 4.5, we're going to look at how this. We're actually going to look at this. The second question we should definitely answer is what students' GPAs were considered. So let me ask you this: who do you think would have a higher average GPA? Students that were business majors, or students that were pre-med majors? So pre-med versus business. Who has the higher GPA? Oh yeah, pre-med. Why? Why do we think pre-med? It's kind of a stereotype, right? I mean, we could do a study, and I think this would be pretty easy to prove. One of the things, I don't know if you all have heard this kind of language about college, second admit programs. Oh, okay, Mike, that's interesting. Business classes might be easier than pre-med classes. Um, that could very well be true, which maybe easier classes would suggest a higher GPA. The point here is that if we only took one group of students, there's a good chance we won't get an accurate description of all students that go to college. So we have to make sure that our sample has a bunch of different type of students. I think C's get degrees is the mantra of business majors, and 4.0s get you into med school is probably the mantra of a pre-med student. Pre-med is a second admit, and I think from when I was in college, there were only 4 classes you had to take. It was Calc 1, biology, chemistry, and A&P, those 4 classes. And those are heavy science classes. And second admit means you aren't guaranteed to get in, you get in based on your scores. So like at Jackson College, second admit would be the nursing program. And Latoya, I think there's some truth about that too. There's some performance requirements in the medical world in terms of like what kinds of grades you need to get to be successful. So most likely pre-med students are going to be have the higher GPA than business students. Medicine is life and death, where business is money, right? So that the point here is that when we generate a sample, when we generate a sample, that sample needs to represent the population. And so we need to clearly understand what we mean by population. It's all the things under study, and sample is a representative subgroup or subset of the population. So in our GPA study, the population is all students, all college students, technically all undergraduate college students. So that's going to be a mix of pre-med and business, music and underwater basket weaving and welding and all the different types of majors and degrees students can pursue. And we want to look at all their GPAs. The sample is the data set we collected. And so we have to make sure that data set has accurately reflects the population. Otherwise, any of the information we get from it is kind of garbage. So it becomes really important to make sure how we collect the sample guarantees we get a representative subgroup. Now, let me give you 2 words that kind of go like summarize sample and population. Population, you should be thinking of the word all, everyone in a group. Sample, you should be thinking of some of the population. So in this case, we are told that the GPA data set was from 70 different colleges, and we're told that this sample is representative of the population as a whole. And that's because the schools that were picked had different sizes and costs and geographic locations. Some were in the South, some were in the Northwest, some were in the Midwest, some were big, large 4-year institutions like maybe University of Michigan. Some were maybe small private institutions like Siena Heights here in Jackson, or of course, there's all kinds of other different types. And so that representativeness means that the sample reflects the population. Right, so our sample looks like the population, so the data that we generate from our sample will also be similar to the data we would get if we collected it from everyone. In other words, this increase in GPA is a good reflection of kind of an increase across the board for populations. Actually, if you go to this website, this guy has some interesting thoughts about this, about GPA inflation. Okay, Let's talk about the different types of sampling, and I'm actually gonna skip what he does here. And I'm just gonna write them up myself in a different way because I think and then we'll look at some of the examples. So we're gonna talk about 4 types of sampling. So the most basic thing that we need in sampling is we need randomness. So we have a very basic, you know what, I can type this, I don't know where I'm trying to. So this means we use process is used to select in subjects from the population. What we mean by a random process is it could be any kind of, like we could roll die and take the number on the die to pick the thing. We can use a random number generator to pick it. We could put all the things in a hat, equally sized thing, and mix up the hat and pick it. If you did the 4-1 worksheet, the Powerball, if you've seen how they pick the Powerball things, there's like this air tube, right, with the numbers on the balls all bouncing around, and then the ball pops up. That's a random process. That's what we mean by random sampling. A key point to this is that each subject is equally likely to be selected. So that connects back to our probability thing from 4-1. The probability of selecting any one thing, any one subject from our population is equal. So everything has the same chance of being selected. That guarantees, if we do everything else properly, this will guarantee a representative sample. Okay, the second type we can talk about is systematic sampling. So when you do systematic sampling, what you do is you number the population, select a random starting point, we'll call that, well, we'll leave it alone. We won't call it anything. And then we select every case subject. So one example of this is like at the border. I went to Canada recently, and I had to pass through the border, and you drive up there and you give your passport and whatever. I saw one car got searched. The car in front of me was inspected. They popped the trunk and looked, had a dog and looked around it. That can be done randomly. And one way you could do that is that the Border Patrol agent randomly searches every 10th car that comes through. Or every 5th car. And then of course there's like, if they suspect something, they're gonna search your car. But if you were doing it as a random process, that's one way to do it, every 10th item. Okay, note, by the way, that there is a randomness happening within that. You randomly start somewhere in your sample or somewhere in your population and then do every 10th. This kth part is what connects to the systematic part. All right, so the next one will. So in stratified sampling, you group the population by common characteristic. So some examples of this are you could group individuals, people by gender, or you could group people by race, or you could group, say, like in the problem we're working on, you could group colleges by geographic location. And then in stratified sampling, you select N subjects from each group. And I should put in here that you randomly select. So you've got all these different groups, and then you grab 10 from each of the groups. Another very common stratified sampling is grouping by age. So, you know, like 13 to 19-year-olds, 20 to 30-year-olds, 50 plus, and then you grab so many from each of those groups. A similar yet slightly different method is called cluster sampling. And with this one, you start the same way. You group your population by some sort of characteristic, whatever it is. And this time you randomly select in groups and collect data from all subjects in the group. A really common cluster sampling method is in quality control, like in a factory setting, where you're producing pallets of stuff. So I used to work when I was in high school, I worked we packaged bird feeders. So all the parts came in and we put the bird feeders together and put them in their little display box and put them on a pallet. You'd have a pallet of like 50 bird feeders. And then your goal was to make 1 million pallets or whatever to make the company all this money. So a quality control inspector would come in and randomly select like 5 pallets and look at every item in the pallet to see if things are packaged correctly. That's an example of cluster sampling. So these are the 4 types of sampling that you would do to ensure that you are getting a representative sample. All of them involve a random process. So all of them have random in it. It's just that these last 3 do a little extra beyond the randomness. Now there's one other type of sampling that's super bad. It's called a convenience sampling. Convenience sampling. And this is any method that does not involve random selection. The data is useless. The data collected is useless for inferences. So when you do a convenience sample, you can't take that information and talk about a population because the sample is guaranteed to not be representative of the population. The most common example of this is late night television shows or like on the street interviews. There are particular election times where it wasn't even just the late night shows. It was even like major news broadcast organizations would go out to like political rallies, political campaign rallies, and they'd find the craziest looking candidate supporter at the rally and ask them questions that they were sure to get ridiculous answers. And then you would infer from that all people who support that particular candidate think like this one person that they talk to. I saw a late night show where they went to like some weed convention in California, and they would ask all these people like, what color is the sky, or some like kind of common question, and the people they were talking to were clearly stoned out of their mind, and they would get crazy answers from these stoned people. And then of course you would the thing that you're to think about is all people who partake of marijuana are similar to these few people we talked to. That is not I don't know that that's necessarily what those late night shows are trying to do, but that is not an inference. I mean, this is part of this is where racism comes from, right? You see someone of a particular race commit a crime or commit a random act of kindness or whatever it may be, and then we're like, hey, everyone from the race is like that one person. Well, that's not true at all. That was one person, one individual from a particular group. If we don't have a process of randomly selecting the people in the group that we're trying to make inferences about, you can't do it. It's not a valid inference. So this is how we take information from a population or how we select individuals from a population to gather information that we're then going to use to talk about the population. Okay, so let's go back to our notes. And I want to I'm going to give you like 3 minutes, or I'll give you 5 minutes to figure out what type of sampling has occurred in each one of these questions, questions 10 through 13. I will leave this typed up. I'll leave this up that I just typed. Where is it? I'll leave this up right next to it so you can see the names. And the goal is to identify what type of sampling method has occurred here. Okay. Set a timer for 5 minutes. When you have your answers, let's do that thing where you do the private chat. Toss it in the private chat and tell me your answers for 10, 11, 12, 13. That'll help me know when to move on. Okay, I got one response. Are the rest of you still working or? Okay, let's talk about it. That was 5 minutes. There we go. So, if you look at number 10, they're selecting 3 states. Now, this states the type of grouping. So we've grouped colleges by characteristic. So that means number 10 is going to be either stratified sampling or cluster sampling. The way you tell the difference is stratify selects some of all of the stuff. Cluster sampling selects all of some of the groups. So if you look at this, they selected 3 out of the 50 states, and they took all of the colleges within that state. That makes this cluster sampling. Does that make sense to you all? Okay, nice. So then for number 11, note there's a numbering, and then we selected every thuff one, right? This is the one that most people get pretty easily. That makes this one systematic. Every 10th one from a particular starting spot. Looks like they started at number 1. Here we get all the colleges willing to release grade information and chose several of them using a random number generator. So here they're just using a random process to select some from the whole population. This is just randomness. And then here's a very clear grouping. They got 2-year, 4-year state and private schools. And then they chose 5 schools from each of those groups. So here they picked some from all of the grouping. That's what we call stratified. Okay. Those are the different methods of doing it. In terms of ranking, it's really which one's best is going to depend on what you're trying to do. So what I would say here is it depends on context. So an example of like maybe a bad one, like if we systematic, I don't know, well, I think they'd all be okay. I'm just thinking of like, so if our question is how are citizens of Michigan's state, how are the residents of Michigan going to vote in the next election? If we do, say, cluster sampling, and our clusters are like all the cities in Jackson, or not Jackson, all the cities in Michigan, and then we randomly select some of those cities and talk to all of the people in it, we're not going to get a very representative sample, partially because our clustering is kind of bad. What we might want to do, or our grouping, what we might want to do is group by precinct, and then randomly select some of everyone in each precinct, which would be stratified, which would be better than just cluster sampling. Because if we did all in a particular precinct, that might be often how precincts are put together. I think precinct is the right word, or district, I don't know. They're often put together based on political alignment. although until recently where we passed the nonpartisan district drawing. So which one of these is best is going to be determined by what kind of question are you answering, what does your population look like, and how is it going to be used. Okay, let's move on to the next piece. So let me reiterate what we've got. We've got a question we've asked that defines a population. The population is often too big to collect data from everyone, or it's too expensive, or there's not enough time to get data from everyone or everything. So we select samples from that. Think about the Flint water crisis. One of the ways they determined that there was a crisis, that there was lead poisoning going on, was pediatricians were noticing it in the young children that were coming to them. And so they kind of had, it wasn't really random sampling, but they were noticing these kids that had high levels of lead in their bodies. And then they could do some sampling of all the children that came into these hospitals, how many of them are ending up with high levels of lead. They could also do some sampling of the different pipes running throughout the city and noticing, collecting water samples from each of those areas and seeing how high was the lead levels. And so what's happening there is you're collecting data, and we call that raw data. And so it's just a list of all the results that we got. One of the ways we like to work with that data is to organize it. Now, it turns out there's two types of data. So let me label these two types of data. So there's what's called categorical. It's also known as qualitative. Oops. So this type of data are things that data values that name tend to not be numerical. So categorical or qualitative data are things like Social Security number. In terms of the government, your Social Security number is your name. It's your ID. Your eye color, your hair color, race, your gender, type of car, like the name of the car. Those kinds of things where it's just a name, that's called categorical or qualitative data. Our example here uses blood type. We can't do calculations with these things. That's a key characteristic. No meaningful calculations. So we can't add up all the blood types and divide by how many. So a second type of data is the name of this class, quantitative data. And quantitative data is numerical data that we can do meaningful calculations. Well, let's just say it's definitely a number, first off, quantitative data. In fact, that's what this class is. Quantitative reasoning, it really just means number reasoning. Like, can you think about numbers? So numerical data, meaningful calculations. That's the two types of data we're going to talk about, and how to define them. We're going to start here with this categorical data. And one thing we do with categorical data is we count up how many of each type of thing do we have. That's called frequency. Frequency means how many. And so if we have categorical data, we can create what's called a categorical frequency distribution. meaning how are the names distributed in this data set. So we're going to have 25 volunteers for medical research. They're given a blood test to obtain their blood types. Here's the data down here. What are our categories going to be? Well, it's going to be the blood type. So A, B, AB, and O. Those are categorical values. And we're interested in how many of each are there. Now, our author likes to put in these tally marks. I don't think they're particularly useful. That's just like, you know how you do that, like 1, 2, 3, and a line through it, or 4 and then 5. All we want to do is count up how many A's are there. So here's how I would do it. 1, 2, 3, 4, 5. Now, really, how a statistician actually does this is they have a computer program that counts it for you. Can you imagine having a hospital that has, say, millions of patients that come through it in a year? And we want to know how many of those million patients had a particular blood type. And really, this is how hospitals might track their needs for their blood banks. Like, we need this much blood because last year we had this percentage of patients that came in needing type A blood. Okay, let's finish this. 1, 2, 3, 4, 5, 6, 7. Then AB, 1, 2, 3, 4. And then O's, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can do a quick check if we got this right. This symbol means sum. It means add them all up. So we could add these numbers up and they should match the 25. So 9 plus 4 is 13, plus 7 is 20, plus 5 is 25. So the sum of these data values is 25, and there you have it. Looks like we did it correctly. So this helps us see the data a little better, right? Instead of looking at this, which is the raw data, we can look at this table, this categorical frequency distribution, and we can see that the most common blood type in our sample was type O, and the least common was type AB. We could also calculate an empirical probability like we did back in 4.1 and say, what's the probability of randomly selecting a patient that has type O blood, and it's 9 out of 25. If this sample was representative of the population, we could infer that this percentage of people in whatever the population has type O blood. Now, these are volunteers, so this is a convenient sample. This is not, we did not do any kind of random process to get them. Okay, so this is, we were supposed to write some conclusions, we did that. Here's another example where you could do this, construct a categorical frequency distribution. I'll let you do that in Alex. There are some questions where you have to do that. And let's take a look here. So what we're working with now, when we start working with numbers that we can do calculations with, we're talking about quantitative data. And often when we're working with quantitative data, if we have tons of data values and there's lots of different numbers within it, where there's very little difference between the numbers, like for this example, weight, we create what's called a grouped frequency distribution. And that is, we take the data set, all the numbers, and we divide them into classes. I already sort of mentioned this, like age ranges. Like maybe we group the 13 to 15-year-olds together. And then we group the 16 to 21-year-olds, and then the 22 to 35-year-olds or something like that. And we count how many people are within those age ranges. So in this case, our author asks us a question. Well, he makes out the point that if we're taking weights of people and we're not rounding to the nearest pound, there's a really good chance that no two people have the exact same weight. So if we tried to do, say, a categorical distribution, it would be meaningless because we would have one of each data value, most likely. So instead we group them. And our author suggests, well, let's do something like 100 to 119, 120 to 139, so on and so forth. And then the tricky question, what do we do if someone weighs 119.8 pounds? Where would they go? Would they go in the 100 to 119 grouping or the 120 to 139? Well, the answer in the stats world is that we do what's called inclusive and not inclusive. So what we would really say is the first class would be 100 to 119.9. 9, right? So what's happening is we're saying that we go infinitely close to 120, but not equal to 120. So here we go from 120 up to, this is often the way we write it, 139, but infinitely close to 139. And you don't round. So this would be put into, this 119.8 would be put into this first class under that criteria. So our author gives us a way to construct these these grouped frequency distributions. You first make a choice. How many classes do you want? And we tend to do 5 to 15. And then you figure out how far apart do you want these classes? Like, what's the width? And to do that, you take the largest data value and subtract from it the smallest data value, and then you divide by what you chose up here. And that gets you the distance in between the consecutive lower limits. So then we do a lowest number as our beginning. We pick a nice one like 100, and we add the width to that to get the next lower limit, and the next, and the next, and the next, and then we count up our stuff. So we're going to do this here with this kind of awful data set. I'm going to do it in Excel because it's super helpful. But let's first answer question 5. So what we have here is all 50 states. This is a population, by the way, because there are only 50 states in the US. Although we could talk about the territories if we wanted to. And this is the record high temperature in each of the states. So if we were to do a categorical frequency distribution, well, we've done it, right? The category here is the state. So it wouldn't be useful to try to organize it that way because we'd have the same, it's the same picture and it doesn't help us any. So instead, we create a categorical distribution. And what our author does is takes the data and separates it from, makes it into, let's see, how many classes do we have here? 1, 2, 3, 4, 5, 6, 7 classes, and then calculates the width as 5. So what he did is he took the maximum in the data set, which happens to be the lowest data value is 100. Oops, right here. The lowest data value was 100, the highest was 134, divided that number by 7, got 4.9, rounded up to the 5 degrees, and that's our class limits. So let's do the example one that he's got here. What we're going to do is create, we're going to do the same thing he just did with Major League Baseball wins by team. So again, we're not interested in the categorical frequency distribution because the categories would be Arizona and Atlanta, etc. What we're interested in are the number of wins. So I'm going to open this up in Excel. I'm going to type in my data values, and we're going to use Excel to find what we want. By the way, project 4 is heavy Excel. We're going to do the whole thing in Excel. So making sure you figure out how to do some of this stuff is super helpful. It's a nice short project, by the way. It should only take you about an hour to 2 hours if you. All right, so first I got to type in data. Okay, here they all are. And one nice thing that Excel does for us, when you select a column, you can filter it. So we're going to sort it from smallest to largest, and that gives us the smallest number and the largest number. So to create this categorical frequency distribution, what we're going to do is first calculate the width. So the width is the largest number, that's this 116, minus the smallest number, that's this 92, divided by how many classes we want. Now, if you look what's going on here, let's see, we've got 30 data values. So if we divide this into 5 classes, we will end up with maybe we could have like 6 data values per class. So that might actually give us a good look at the data set. The other thing we could look at is what is the distance between the largest value and the smallest value? What is this width? 24 is a number that's nicely divisible by 6. So let's do 6 classes. We could do 5, but let's see, if we divide by 5, we would end up with the same, we would get a distance of 5 wins between each, and this nice 4 between each. It just kind of seems nice and convenient. So what we do is we calculate a lower limit, or we choose a number for the lower value. Let's see. So our lower value is, our smallest number in the data set is 92. We'll be adding 4 to it. Let's use 92. That seems okay. And then what we're going to have to do to that is add the width to it. And then we chose 6 classes, so we need to do 6 of these. Oh, man, I'm just going to do this so I know we get to 6. So I'm adding 4 each time. These are all the lower limits for our classes. Now our upper limits are always going to be 1 less than the previous one. So 95, 99, 103, 107, 111. And if I had gone 1 more, this next one would have been 116. So we're going to put in here 115. Now notice this does create a problem for it, because that means these last 2 data values would go into the next class. So how do we want to fix that? If we did 7 classes, how would that look? Well, we could do 7 classes. That's what we can do. So if we did 7 classes, you would still want to round up to the nearest next value. So you would want 4. You would still make this 4 and have 7 classes. All right. Then the next thing is just to calculate the frequency. So we want to count how many numbers are between 92 and 95. Now, when you select them, it's probably kind of hard to see. Way down here, there's a count thing. So this tells me when I see these 2 numbers, there's 2 of them. And then 96 to 99, I selected all those, and down here, I get a 6. You probably can't see it. Super tight. Then we go 100 to 103, I've got 7 there. 104 up to 107 is my max. That is 6. And then 18 up to 111. That would be 6. And then 112 to 115. So there's only 1, and then there's 2 in the last. And then if you recall from project 1, you can use the sum feature. We can add up the frequency to make sure we actually have 30 in there, and we do. So this would be our frequency distribution, our grouped frequency distribution. How you all feeling? Why is this not showing? Here we go. Okay. So once we've got this stuff into a grouped frequency distribution. Oh, yeah, question. Oh, good, Latoya. So once we've got this into a group frequency distribution, sometimes reading that is not the greatest, right? Yeah, that's we see that, right? But maybe a picture would be a better way to do it. So a picture of a grouped frequency distribution is called a histogram. It's really similar to the bar graphs we did back in Unit 1. And what you do is you just draw a graph of your data, or you draw a graph that has those data values in it. So let me pull this up and do it. So the x-axis is the lower limits. So I'm going to start at 92, and then I'm going to go to 96, and 100, and 104, and I'm just going to do a few of these. And then what we would do is graph the y-axis is the frequency. So 1, 2. This is really hard to do by hand. The 96 to the 100 was 6. 2, 3, 4, 5, 6. The key thing is these guys need to touch, and there it is. So the nice thing is that our Excel will draw this histogram for us. So I selected this, and then I'm the numbering of the classes, and I'm going to go to Insert and where is it? And I want histogram, which is this one right here. Interesting. It did not do what I wanted it to do. Well, so I'm going to have to look up, I'm going to have to work on that. It doesn't want to do the histogram. The bar graph will get us close to it. No, it doesn't. Why is it doing? Well, it doesn't want to do it for us. I will have to look up how to do that. Instead, why is the screen so bad? This is what it would look like. And I will figure out what's going on in a second. I'll give you a chance to do this. Next one would go here, and so on. Okay. He gives us an example of one right here. Man, what is going on with this? Where he takes this frequency thing and draws us a nice little. Okay, what I want to do actually is give you a chance to try this. So get your worksheets out. And grab the 4-4 worksheet. So this might get fixed. So here's the 4-4 worksheet. And you are to make a group frequency distribution for these numbers. Oh, I think I got a new version. Yeah, here we go. So let's go to question 5. You're going to take these numbers and create a group frequency distribution. I'd encourage you to do it in Excel. So let me give you 5 minutes to try it. And then you ask me some questions for the timer for 5 minutes. Hey, y'all, how are you doing? What'd you get for the for your width? You want to calculate that? That's
How do we calculate the width again?
biggest number minus the smallest number divided by the number of classes. And I would say in this case, I would use 5 classes because there's so few data values. So to get that width, you would do 29,601 minus 9,369 divided by 5. So that's 4,046.4 between each. So maybe we'll do 4047. So then you want your lower limit and your upper limit, and you got to pick a starting value for the lower limit. So maybe we do 9,360. And then you would add this 4047 to each one of those until we had 5 numbers here. And then you're just going to count how many of each value is in between that. So if I'll do the next lower limit. That'd be 13,047. So this upper limit would be 13,046. So then what we're going to do is just count how many of these numbers are between these two values. So that's all of these, 1, 2, 3, 4, 5. So there's 5 of them. And we do the same thing with the next one. Add 4,047 to this. Subtract 1 from that, get the upper limit, count how many numbers are in between, and then you'd have built your grouped frequency distribution. Does that make sense?
And where did we get the 5 from? That was because of the 29,601 minus the other one divided by 15.
I picked it. That's the part everyone hates. You pick that number.
Okay.
If you go back to the textbook, he says you're going to pick you decide how many classes we want. Actually, it's right here. Where's it? Right here. And you pick between 5 and 15 classes. And it's based on how many numbers do you have in the data set. So if you have millions of numbers, you would probably pick 15 classes. If you have, like in our case here on the worksheet, you only have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You only have 15 numbers. So you don't want to have a ton of classes or you won't see much of the shape of what's happening with the data. Okay, let's go back to the notes. I'll let you all finish that up. You don't have to use the exact same thing I've done. You could use something different. If you want to do more classes, you can. It's up to you. The next bit, the next way to organize is stem and leaf. I don't know why. So, here. Let me erase it here. Yeah. Okay. All right. Computer's glitching up on me. Here we go. So let's take a look at a stem and leaf plot. So a stem and leaf plot is it's just another way to organize data. And what it is you take like when you take 2-digit numbers, you have a portion that's called the stem, and that would be the tens digit. And then the portion that's the ones digit is called the leaf. And you write them like this with a line in between. And then you've got a little key that tells you how to read this. So for example, if I circle this number, that is the data value 4.5, because my key tells me that the stem is the ones place, the leaf is the tenths place. And what's nice about these stem and leaf plots is it's a graphical look at the shape of a data set, and it also has all the data values in it. Like if we compare that to a histogram doesn't give us how many values are in, say, in each class. So what I want to do is take a look at, I just kind of want to do the stem and leaf plot. Well, let's do this stem and leaf plot, this very last one. So these are the National Insurance Crime Bureau. This is the very last question in your textbook, so I've skipped way down to the end. So this is the number of registered vehicles per car stolen for 35 selected cities, United States. For example, in Miami, 1 automobile is stolen for every 38 registered vehicles in the city. So kind of an interesting data set. What I want to do to help us out is I'm going to put these values in Excel, and it will sort them for us, which is part of the problem when working with data values, especially if they're not in order. And that's really what the stem and leaf plot is to help with. So when we build the stem and leaf plot, it's helpful to have the numbers labeled from smallest to largest. They are, and I'm going to sort them from smallest to largest. And there we go. This will help us build our stem and leaf plot. We've got these all to the nearest whole number, which is helpful. And what we're going to do is build our stems. They will be the whole numbers, or the tens place, and our leaves will be the ones place. So if we look at the data set, we have 3, 4, 5, 6, 7, 8, 9. We go all the way up to 90. So the stems will be 3, 4, 5, 6, 7, 8, and 9. And then what we're going to do for the leaves is we list the ones place number for each of these. So let me make these a little bigger. Oh, come on. So there's only one number that's in the 30s place, and that's the 38. So we list that here. And then in the 40s, there's only one number. That's 41. The 50s, we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to list all of those. And it's kind of important to try to line these up nice and neat. It's a little hard and using a mouse to write. Even with your paper and pencil work, it's a little hard. So you notice I'm taking each of these ones place numbers and listing them in order from smallest to largest. We'll do the same thing for the 6s. I have a 6, 8, and 2 9s. And the 7s, we've got, let's see, 2 0s, 3, 4, 5, 8. 0, 0, 3, 4, 5, 8. And then for the 80s, oh my, we got a lot. 0, 1, 3, 3, and then 3 4s. 2, 3, 5, 7, and 3 9s. It. And then a 0, a 2, and 4. So there's our stem and leaf plot. We need to provide a key for how we did it. So it should look like that. This is just another graphical representation of kind of the distribution of numbers. Notice we've made our classes, if we were to compare this to a group frequency distribution, we've made our classes go from 30 to 39, 40 to 49, 50 to 59 in this case. We could draw a histogram out of this because not only are these actual data values, it's the frequency within each class. So this has only 1 in it. This only has 1 in it. This has a bunch. There's a couple, a few more. And this would be the same thing as a histogram, only it's on its side. So if we rotated this, we would have the typical histogram that we draw. Okay, so your job then on the worksheet is to take the same data set that you did here and turn it, create a stem and leaf plot. So what I'm going to suggest you do is that you take the thousands place and make that your stems and make the leaves these other numbers. So like, for example, I would say that maybe your key could look like this, 9,000. This is 9,369. And so then you're writing groups of 3 numbers for each. Okay. I think the other question that often gets people is this one. I'm wondering how interested you are, and maybe I should give you like 5 minutes and try to identify the sample and the population from this problem, and then let's talk about it. See if you got it, and then that'll probably take us to the end of class. Set a timer for 5 minutes. Okay, how'd you do? Anyone know the sample?
I'll give it a shot.
Say it again.
I'll give it a shot. 1,003 registered voters with landline 167 and cell phone 836.
Love it. So you can just, that's the good start. That's good. That's breaking out the two, but that's it. It's the 1,000 registered voters. Nailed it. Excellent, Mike. The tricky one then is what's the population?
U.S. registered voters with phones.
Yeah. I think the intention here is that it should be all US voters, really. I agree with you that the sample only talked to people with phones, but my guess is these researchers are interested in what do all Americans think. This was a poll conducted. I don't know if this poll is still available. It was done by Fox News back in 2021, right? And the way they surveyed people was only by phone. So one of the questions we could ask ourselves is, do we think this is representative? What percent of the US population does not have a phone? And it's probably not very high. I'm sure there's a few people out there that don't have phones, but this might be a fairly representative sample. Note that they did do it randomly, so it should be good. Okay. Did you all feel like you could do these? I think this is just unit 1 stuff. Like, can you calculate a percent of? I don't know if you all feel like you need help with that or not. I'll leave that to you all to figure out, and let's glance at the project. So for project 4, what you're going to do is there's a data set I'm going to give you in Excel, and it is salaries of Jackson College employees. So there is a group out there. It's called the Mackinac Center, I believe, that collects data on all kinds of data. And one of the data sets they collect is the salaries of the state of Michigan employees. And a certain set of Jackson College people fall under that umbrella. And so every year they file a Freedom of Information Act. You are, as a citizen of America, or as a resident of Michigan, you could do this too. And they request the salaries of all Jackson College employees. And then they post those salaries by name and the amount the person makes. So if you wanted to know how much I make, you can go to this website, see my salary. So I'm going to pull up this data set. I haven't loaded it up yet, but I will load it. I'll put it up there for you shortly. Oops. So this is what it looks like. Wait for it. Here we go. So it's just a list of data values. I've got them organized from largest value, $131,720.41, down to the smallest value, $755.60. Now that is that value is probably like a student worker. It's probably not someone who's working full time. I mean, that would be crazy. Who could live on $755? So your job is to pick a sampling method and do it. So you're going to pick one of these 4 methods that we've done, that I've identified, and you're gonna generate a sample. And the sample size happens to be size, you need 25 items in your sample. So I think one of the easiest ways to do this is to do a random sampling. So here's how I might do it. First, I'm going to list 25 values. Then what I can do is Excel has this random number generator. So if you do equal and type rand between, this allows you to list 2 numbers, and Excel will randomly generate a number between those 2 values. So if you look at how I organized the quotes population, it was numbered 1 to 34. So each salary corresponds to one of those numbers. And this randomly selects those values. So here we go. There they all are. Now, one of the problems with this particular function is that every time you do something in Excel, the numbers change. If I type 7 in here and enter, all of the numbers suddenly changed. So one way to fix that is to select it, copy, and then paste the values. So here I've got the original same values. Here they changed. So I'm just going to ignore these because they're going to continue to change. In fact, I'm going to delete them. And now I have randomly selected 25 numbers. And each of these numbers correspond to a salary over here. So what I would do is go to number 17. I would select that salary and paste it in here. I would go to position 103. Select that salary, paste it in here, and then I've randomly generated 25 data values. That would be my sample. That's one way to do it. Another way to do it is, so this is, another way would be to do a systematic sample. And the systematic sampling has you pick a random starting spot. So let's do a random number, just like we did. I'm going to pick between 1 and 34 because those are all my options. And I'm going to randomly start at 125, and I'm going to pick, let's say, every 10th value. So randomly start at 100, 109. Remember, it kept changing. And so I'll go to the 109th data value, and I'll select that one. And then I will go now to the 119th data value, select that one, and keep going. Every 10th value, I'm going to toss in here. So eventually I'm going to run out of values. Here I'm at 129, but then we'll just circle back around. So when I hit 133, that's 1, 2, 3, 4. And then I'll get back up to the top, 5, 6, 7, 8, 9, 10. So now I'm at the 6th value, and then the next one would be the 16th, and so on and so forth. Does that make sense to you all? That's really all you're ready to do for the project, is to generate that sample. We're going to learn about measures of average and measures of variation in sections 4, 5, and 4, 6. That's what we'll be doing on Monday. or sorry, Tuesday. No, what is today? Wednesday. So Monday of next week, and then Wednesday of next week, we'll be looking at the normal data, which is what you need to do on this thing, and misleading information. And then we'll be done with this semester. It's kind of crazy. So what I encourage you to do is to look at this project, get it downloaded, get it ready to go, and get your sample selected. I'm going to dump that data set up there, and so you can get that done. Yes, let's do the lesson check for today too. What is this? The 4.4 lesson check. Oh yeah, we already did it. Let's see. So the 4.4 lesson check is question 12, which is this one. And this was random. You know, the same thing. Thank you for reminding me that. Okay, you all, have a great weekend, and we will see you next time. If you have questions, I can hang out and answer them. Otherwise, the end is near.